Thank you, everyone, for joining this session. I know it's the last one. I hope you had a great day here at Cube Day Israel. I know that I enjoyed most of it and talking to most of you. I'm actually really excited to give in the closing session with all of you. Today, we'll be speaking about how to simplify your multi-cluster management using a tool called Karmada. A little bit about myself. My name is Eliran Bivas. I'm the architect for the platform group at AppsFlyer. I work for AppsFlyer for almost 4 years now. I have a real passion for technology, so if you look at me in LinkedIn or any other place, you will see that I am a self-proclaimed tech junkie. A little bit about AppsFlyer. I'll let the numbers speak for themselves, but I'll read out some of them. AppsFlyer is the market leader for mobile attribution. We operate with 14,000 customers and 65% of the global market share. We have about 1,500 employees that operate across the globe. A little bit about the engineering organization that I'm part of. The engineering group has about roughly 400 engineers divided into squads that operates around 1,200 microservices that handle roughly 3 million events per second. And we operate an infrastructure that is close to 250,000 cloud resources and dozens of SaaS integration and more. The reason it's roughly a number because our infrastructure, as with any other large organization, is growing or shrinking based on the demand and the customer requirements. So a little bit about the agenda that we're gonna talk about today. We'll start about the challenges of working with large-scale clusters, and we'll introduce Karmada and understand what is architecture and a little bit about its API. I'll go over several use cases just to demonstrate the use of Karmada and how it should simplify the use of multi-cluster management, and we'll conclude what we discuss in this talk. So let us begin. I'm pretty sure that all of you are familiar with this logo. If not, this is Kubernetes, of course. And I guess for over the years, we learned to love this tool. Love or hate, it's a matter of perception. We learned to love it because it has a decent scheduling mechanism. It has a simple, yet a very robust API to describe our requirements. It has a lot of built-in goodies, like service discovery, has node failures, and countless integrations that targets specifically Kubernetes. It's enough to look at the CNCF landscape just to understand how many different organizations or startups or frameworks target Kubernetes as their infrastructure operating system. But when you reach a certain scale when operating with Kubernetes, it forces you to rethink your entire architecture of how to manage that scale. And when it comes to large scale, there are basically two options for scaling your large-scale clusters. Either you can go with vertical scaling, having a very large disco ball that you keep growing and growing and growing. Or the other way is to use many clusters, basically try to have as many balls as possible and juggle with them. Each approach has, of course, its advantage and some drawbacks, and I'll try to list some of them in the following slides. First, let's start with the vertical scaling, the very large disco ball. So having a very large disco ball, it's basically your single point of failure in your organization. If something happens to that cluster, your entire production might be in jeopardy. So having a single point of failure is a big no-no in most of our organizations. Another is scalability limitation. You can't really have the ball that big. Kubernetes itself has a limitation for its clusters. You can't really reach more than 5,000 nodes. In some cloud provider, you can't even reach 3,000 nodes. There is also a limitation for pod per node and other limitations that prevent you from growing even larger and larger. Another issue that you will have is resource underutilization. You're going to schedule large workloads operating alongside smaller ones. You get a lot of fragmentation in your bin packing, and the cluster is becoming underutilized. Another thing is the complexity of managing a very large cluster. Just think of a simple task if you would like to, let's say, upgrade the cluster API. How long did it take to do a rolling upgrade for a 3,000 node cluster? And it takes quite a while. Next, we have a horizontal scaling. So now, instead of managing a single cluster, we're going to manage multiple clusters. So just by introducing many clusters, we have a complexity of management of multiple clusters. For example, at AppsFlyer, we manage hundreds of Kubernetes clusters, and we have different flavors of cluster. We have clusters that are targeting Kafka, we have clusters that are targeting Airflow, Spark, services, and many, many more. Each require different type of management and different kind of workloads. So the entire complexity of managing them has become an issue. Resource allocation, this is again another difficulty that you need to face with. Basically, when you have so many clusters, which workload you are targeting to which cluster? How do you manage it? So your resource allocation become an issue that you need to work with. When you're working with many clusters, your entire network becomes a complexity on its own. How you do interconnectivity between clusters, which clusters allow to talk to which. And this is a very big challenge if you're facing with service discovery, because now we need to do service discovery across multiple clusters. So this is, again, another challenge. And of course, the last drawback when working with multiple clusters is you have a potential to have an inconsistency of your configuration. Basically, did we install the right controller in all of our clusters? Do we have the same API in all of them? Have we deployed the right deployment to each of our regions? It's a drawback when working with so many clusters. So this is where actually Karmada comes into place. And I'm going to read out loud what basically Karmada is. Karmada, which is a short for Kubernetes Armada, is a Kubernetes management system that enables you to run cloud-native application across multiple Kubernetes clusters and clouds with no changes to your application. So just by this short statement, we are talking about not just multi-cluster, we're talking about multiple regions, even running on multiple cloud providers. Now, this is a very strong statement, but basically Karmada is aiming to manage your entire global availability of your production. So let's do a short dive into Karmada's architecture. Karmada's control plane is trying to mimic Kubernetes API, so you're going to be familiar with most of the examples I'm going to show you because you're already natively working with Kubernetes. So Karmada's API server mimics the Kubernetes API server. We have a scheduler, but now instead of scheduling to nodes, we are scheduling into clusters. And there are multiple controllers that consist the entire control plane. One of them, just for an example, is a cluster controller. So if you're familiar with how Kubernetes itself operates, we have a node controller to operate on the node level. Here we are operating on cluster level. There are two options to integrate with the control plane. If you have a cluster that you want Karmada to integrate directly, meaning a push, Karmada will integrate directly with that API server and push the workflows directly to that cluster. Other option is, of course, the pull using an agent. The agent will connect to Karmada's control plane and fetch all the workflows to that designated cluster. A little bit about the primary concept that Karmada is trying to align with. Basically, we're trying to work with these three, and I'll later on demonstrate how they are coming into action. First, we have a resource template. Resource templates are the native Kubernetes API you're already familiar with. If you know how to work with a deployment, a service, secret, config map, or whatever, it will become available into Karmada's API as a resource template. Any other existing tool that you're currently working with in Kubernetes will become available for you when working with Karmada. There's no need to change anything. Next, we have a propagation policy. The propagation policy is basically the multi-cluster scheduling that allows you to do a one-to-many scheduling, having the template propagate to any other cluster that you would like. And last, we have the override policy, and the override policy is a cluster-specific configuration that allows you to change the propagation into a much more specific and individual for each cluster or a group of clusters. So let's look at the API flow, for example. The API starts with a resource template. And as I mentioned, everything that is native to Kubernetes, it's native to in Karmada. So a deployment, config map, and so on, you're submitting into Karmada's API. Alongside with the propagation and the override policy, everything comes into action. Karmada knows how to push that workflow directly to the designated cluster. Internally, it creates an object called work. This work object is responsible to reconcile or synchronize to each of the specific clusters. Now, it doesn't schedule on the cluster itself. The cluster knows how to schedule deployment or a config map. It knows how to handle a service. It just communicates with the designated cluster through the API and tells it, you need to work with that object. Internally, everything keeps working as it should. Now, in most of the diagrams that I show, and later on in some of the other examples I will show, when you're looking at diagrams, usually in Kubernetes, squares are nodes, okay? It's pretty simple. We see a lot of nodes, a lot of squares. In Karmada's diagrams, each square is actually a cluster. So it's a much larger scale that we're accustomed to see. So let's go over several use cases to demonstrate the multi-cluster API that Karmada provide. I have to say that due to some limitation, specifically space in a slide, I wouldn't be able to show you a complete armada of clusters. I'm going to demonstrate with only 2. But just for the sense of it, think of it if we had multiple clusters in the US, in Europe, in Asia, and maybe in Africa, the entire slide will be a lot of squares. So I'm going to show a very few initial use cases just to demonstrate it. Let's start with the simplest item that Karmada supports. It's, of course, scheduling, how to do multi-cluster scheduling. And in this example, as I mentioned earlier, we're working with native Kubernetes API. So this is a deployment. I hope you're familiar with it. But it's nothing related to Karmada. It's a simple deployment that we submit to Karmada's API. Nothing special, but nothing happens. When we submit it, this is actually a resource template. Nothing happens on either of the cluster that we are connected to. So if we look at the next step, is the propagation policy. This is the multi-cluster API that Karmada provides. Part of the principles that Karmada is operating with. We are defining a propagation policy, and just for the sake of the example, I use a static propagation, okay? Just for a short demonstration, you usually wouldn't use static configuration. But in this case, we have 2 clusters, one in the EU, the other in the US. The EU one called EU West 1. The US one is East 1. Pretty simple. In this static configuration, I'm going to say propagate that deployment that I defined earlier to EU. This is what Karmada will do. Schedule it in EU West 1. Nothing really happens on US. Simple. And again, any square that you see here is a cluster, is not a node specifically. Karmada's API is a cluster. Each one of the EU and the US cluster are fully functional clusters. Next, a more advanced scheduling, maybe with Affinity. Again, this is something that you are familiar with when working with Kubernetes. I'm going to add a label for each of my cluster, one label that's called location, based on the continent. In this case, we'll have 2. And I'm going to deploy all of my resource templates to the US clusters. So if we'll have multiple clusters, not in this example, will deploy all of the resource templates, the resource template to all of our US-based clusters. And a slightly modified scheduling mechanism is an API that is using, again, match expression with labels. Now I'm targeting the US and the EU. Our Asia and Africa cluster will not get any propagation defined. Next, let's see how the override policies come into action. Again, this is a multi-cluster API that Karmada provides. Maybe due to some privacy issues or other business constraint that you have, you need to change the way that services are deployed to your US-based clusters. You're basically using the same label selector as before, and now we are saying, okay, for that cluster, I'm omitting the overriders and what are the possibilities there. For example, let's say we're going to use a different environment variable or an image, and now Karmada will schedule the same deployment, but with the overriding scheduling of cluster in the US. A failover. This is another internal mechanism that comes within Karmada's API. I updated the example a little bit. Now the deployment has a replica set to 3, so meaning that if we'll schedule it on a regular Kubernetes cluster, we'll get 3 pods, right? This is the definition. Again, I'm deploying it to Karmada's API. It's becoming a resource template. And again, I'm going to talk about cluster failover, not node failovers. Node failovers is something that Kubernetes knows to do without Karmada, so it doesn't really need to handle it. But this is, again, a failover mechanism that slightly have a more advanced propagation policy. And again, I'm using a static configuration just for the sake of the example. In this case, I'm going to use preferences of a weighted cluster, meaning that I want to change the way that everything is split across my Armada. I have a scheduling type that's called divided, meaning that I want to take the entire weight and divide it across my entire clusters. I can also use replicated and other strategies. Again, just for the sake of the example, I've used a weighted and divided because it's much, much easier to understand. And I'm going to use the static weights, 2 to the US, 1 to the EU, meaning that 2 pods go to the US, 1 to EU. And again, Karmada doesn't schedule the pods themselves. Karmada is scheduling only the deployments. And those deployments have a slight different propagation based on the propagation policy that we define. And when they reach internally into the designated clusters, 2 pods appear in the US, 1 pod appear in the EU. And now catastrophe happened. Maybe an entire region has failed, or maybe something that we did that causes our cluster in the EU to shut down. In this case, Karmada will identify it and will simply reschedule the deployment, not the pod, and change the way that the number of replicas will represent the desired state that we wanted. 3 replicas, now everyone will be in the US. Another example for Karmada's multi-cluster API is service discovery. And now, this is something that I personally find very interesting. It's something I'm contributing to this project. I wish to keep contributing to enhance its features. We'll start again with a very simple example. We have a deployment and a service. I'm going to omit the propagation policy just for the sake of the example. We propagate it through the Karmada API and have it on the EU West 1 cluster. So now everything runs very simple. We have a deployment and a service that connects into it. So everyone that accesses the service locally will reach the deployment, right? Simple, still Kubernetes. When we employ the multi-cluster services API, we say that we want to export that service from the US cluster, from the EU cluster to the US cluster. We export from one cluster and import to another. Again, I'm omitting the propagation, everything else, but once we'll have everything running, we'll have a service defined in the US that basically once the services will reach it locally, will reach the EU cluster without having to know that there is no local deployment. Now, there are other possibilities, other strategies for service discovery. You can do failovers. You can do other options how to do service discovery in multiple clusters. But this is just the simplest example of having a service that basically does a direct connect to another cluster. But with all the thing that I just demonstrated, you have to understand that all of the examples that I recently showed you possesses some risk. Okay? And the risk is, it's if you've seen the YAMLs and read it closely, you will probably see that the API version was v1 alpha 1. Meaning that while some companies do use Karmada in production, you have to understand that this is a CNCF sandbox project. As a CNCF sandbox project, it means that the API is not finalized or should be considered stable. Okay, so if you're planning on using it, you should definitely consider the risk of using a sandbox project. And as a sandbox project or any other open source project, it requires a lot of contribution from its audience and users. First, you should access the website in karmadas.io. There's a lot of documentation that the team has provided, a very well-documented code and a very well-documented feature set. You can also open a lot of issues and contribute, of course, code to their GitHub repository. It's highly appreciated. And of course, join the discussion. There are a lot of discussions over the CNCF Slack over at Karmadas, and any contribution will be much helpful. So let us conclude a little bit about what we discussed in the past 20 so minutes. First, we discussed about Kubernetes and how it used to ease our work, our operational work. We mentioned that once we reach a certain amount of scale, we need to rethink our operating strategy. We talked about vertical scaling versus horizontal scaling, having the disco ball versus number of balls, and what are the downsides for each of the approaches. And last, we talked about Karmada, its architecture, and very initial use cases just to get a glimpse of its multi-cluster API. Thank you very much.
Thank you very much, Eliran. And we have a few minutes for questions. Any questions from the audience? Okay, I see a few hands here. Let's start here.
So my question is regarding your experience in scaling at AppsFlyer. Before you, when you made the decision to scale horizontally, what was the limit that you discovered practically on vertical scaling? On horizontal scaling of a single cluster before you decided that you had to go split workloads to multiple clusters? Like,
in AppsFlyer, we decided that we immediately going to go with horizontal scaling because of the amount of different workflow that we have. Since we have workflows that targeting Kafka, Airflow, services, they're all different in shapes and sizes, so we immediately started with horizontal scaling.
Next question. Okay, here we go.
Hi, can you please say how Kafka is different from OCM, Open Cluster Management, and why would I choose one over the other?
I guess this is a topic for another for another conversation. So maybe we could talk.
Yeah, let's
after, because it's a big subject, and I can actually fill in another 30 minutes for it.
Okay. More questions? Here you go.
When you deploy an application across multiple clusters, and let's say it deployed and everything went successfully, who's responsible for the deployment if it, let's say, changed somehow, someone changed it, so it looks on it and checks if it changed and reverted to the initial state?
Okay,
because, so... And I ask it because, let's say, if I use Argo CD, to manage my applications and I want to deploy all the application across multiple clusters, I can use both, but since Argo CD is the manager of the application, it might change something, and if this one will change it back, it will go back and forth.
I think you kind of answered your question, because the key here is GitOps. You basically need to have the entire API propagate with GitOps. Okay, so if you are managing today your entire clusters with Argo CD or Flux to manage your clusters, you basically have the same notions of GitOps. Everything, the source of truth for you is still your Git repositories. So if something changes across the cluster, it will propagate again and reconcile to your source of truth.
More questions? Okay, we have here at the corner. Here we go.
Okay, a couple of questions about Karmada. First, does it also handle things like changing of Kubernetes versions, or it just handles the deployment? And following up with this question, does Karmada have GitOps of its own? Because if I understand correctly, instead of writing infrastructure as code that goes directly to the Kubernetes cluster, you have to write infrastructure as code that goes to Karmada to handle all of it. So it should have the same tools of managing code and configuration on its own.
So I'll start with the second one, actually.
All right.
But no, it doesn't have its own GitOps. It relies on reconcile itself. This is why it has Karmada's API. And you're supposed to bring in all your YAMLs and configuration from another source. In this case, maybe Argo or maybe Flux to bring in your configuration. It's that answer the second part of your question? I guess. Okay. And for the first part, I need you to ask it again. Sorry.
So you mentioned a few drawbacks of using multiple clusters, like inconsistencies of configuration between clusters. How does, if it does, Karmada resolve those issues?
It actually doesn't. Okay, this is part of being a sandbox. It doesn't really target it yet.
Any other questions? Just a second. Here we go.
In the example you gave with deployment of multiple replicas that got divided between two clusters, how is pod disruption budget handled in that example?
You basically, if you know how to work with pod distribution budget in a single cluster, it's the same with in Karmada's API. You submit it and propagate it to the clusters, and it will keep working as the same.
But if my deployment is, let's say I want to have a max of 1 unavailable, but I have one cluster with one deployment, with one replica, and another cluster with 2 replicas, what would be the PDB that gets set on each of those?
So I showed a static configuration. Mm-hmm. So usually wouldn't use that a specific number of pods. This contradicts working with auto scaling and contradicts budgeting and so on. So if we're working with budgeting, there is another API for that. Okay, I didn't show it because it's a much more advanced one. But Karmada knows how to handle it. It's a different one.
There's a question on this side of the house. Yeah. Here we go.
Yes. First question, CRDs, are they supported or?
Yep.
Okay, that's good. And the second thing, some infrastructure as code providers like Pulumi and Terraform rely on the status of the deployments. So in this case, because one deployment is actually multiple deployments, how does the status field change? I'm sure it's not like the same as one single deployment.
So Karmada's API is the source of truth for you. If you usually if you deploy with Terraform looks at a single cluster, right? But now we are working on multiple clusters. So Karmada is your entry point. So Terraform operates on the Karmada API level.
No, that's not like if you apply deployment to a cluster in Terraform, it waits on the deployment status to be complete. So in this case, what's the status? Because there's 10 clusters and I'm sure it's a different syntax, or do you even have like a status that's...
Yeah, it's the native. If you'll do kubectl describe the deployment, you will get the status of it, as if it was running on the Karmada's API.
Oh, so like the complete is on every single cluster combined?
Yeah.
Oh, okay.
Thank you very much, Eliran. Great round of applause. Great talk.